First off, welcome. Team Systems Engineering is excited to welcome you as part of our community. We're excited to have you engaged in this very new area. We're excited to provide you the tools necessary to engage in being problem solvers in a complex, VUCA, vulnerable, uncertain, complex, ambiguous environment. Your first step to this journey is this course, SE301, Fundamentals of Engineering Design and Systems Management. I'd just like to introduce you to the course, let you give you an idea on what is it you're about to experience, and then take you through over the next 15, 20 minutes what to expect in the course overall and get into some initial board problems. We're going to talk about systems and systems thinking, the systems decision process, and overview of systems engineering. So what is a system? Well, a system is all around you. If we think about if you're on any sports team, for instance, you play soccer, a ball is part of a system. The system, the ecosystem is the game. And the players are also part of that system. So are the umpires. If we think about NASCAR, not only are the cars part of the system, but what about the pit crew? What about the supplier that drops off the tools necessary to change the tire? A larger system, and something that just happened recently, was another rocket launch. Well, a rocket launch is a system of systems. And for all of you who will end up in the Army as officers leading fantastic organizations, you will be part of a system, and you will have many systems, be it radios, unmanned aerial devices, autonomous vehicles. So you will be part of a system. In a formal definition, which is in the Parnell book or the green book that you all have, a system is an integrated set of elements that accomplishes a defined objective. These elements include products, processes, people, information, techniques, facilities, services, and other support elements. And one way to approach these systems is leveraging something called systems thinking, a holistic mental model and worldview that recognizes a system as an entity first, as a whole, with its fits and relationships with its environment being primary concerns. This is one way to define systems thinking, and you will be exposed to a different way or that's additive or different lexicon around systems thinking in the Cabrera book that you have. And this is an idea of a systems iceberg. So if we think about an iceberg, all you can see is the small peak at the top, and that's what we're reacting to. But much like most icebergs, there's a whole lot more below the surface of the water. And so as systems thinkers, how do you develop your mental models in order to transform the structures of your systems to design what's needed to allow you to anticipate how to solve these complex problems? So there's a connection between systems thinking and what's under the surface, not just what you see on top of the water. And systems thinking is actually part of the first phase of the system decision process that you're going to be exposed to throughout this course. The first phase is problem definition. Why is it problem definition? Because this is the hardest portion of any problem. What is the problem? Asking the right questions, understanding what the stakeholders needs, doing your research, and better understanding what are the requirements required. The output of that problem definition phase is a redefined problem statement and value model. Once we transition, the next step is solution design. And why is it yellow? Well, if we go back to problem definition, it was red because you had to stop, because it's the hardest part of any decision process. But the solution design phase is yellow because it's just a pause. Let's pause and make sure we've developed feasible solutions. Let's ensure that we've considered what the decision maker needs, and let's perform those initial cost estimates. Because we can't, as Einstein highlighted, we can't solve problems by using the same kind of thinking we used to create them. And once we're done with solution design, we now have these candidates for solutions. And that allows us to move to the decision-making phase, which, why is it green? It's kind of like just like a stoplight. It's green because that means you can go, you can move forward. You've collected data, you're running models, you understand what the stakeholder requires. You've done sensitivity analysis to really understand your upper and lower limits, and you're applying value-focused thinking. And nothing is more difficult and therefore more precious than to be able to decide, as Napoleon highlighted. And once we're done with decision making, you go on to solution design. Your solution decision is solution implementation. Now, as we look at this system decision process, you're going to go through this whole process throughout your time in this course. But we're going to focus on the red phase, the problem definition, and the yellow phase. How do we think about solution design to ensure that we have those locked in, understood, we're clear, we understand all of the elements of these things. Because once you become a firstie, you'll be in a year-long capstone course or semester-long capstone course where you'll be able to go through the entire system decision process with the idea for potentially being able to implement or providing a way to implement for a client. And so you may wonder, well, how does this SDP, system decision process, that we're exposing you to, how does that get implemented? Well, there's implemented in many ways, and it allows you to really break down complex problems by leveraging emerging practices, complicated challenges through analysis or good practices. Sometimes the best practices are pretty obvious. We know how to do those things. And then the SDP allows for you to bring order to chaos. So it kind of allows you to bring all of these different facets together and bring order where there exists disorder. And in system engineering, we describe system engineering in the systems engineering department at West Point as more of an integrative discipline. It's more interdisciplinary. System engineering is an interdisciplinary approach and means to enable the realization of successful systems. It focuses on defining customer needs and required functionality early in the development cycle, documenting requirements, then proceeding with design synthesis and system validation while considering the complete problem. And a standard way of viewing system engineering is through the systems V. The left side is where we define the problem and we better understand life cycles and we design what's going on. And then once we hit the trough or the bottom of that V, we go into the other side of the V where it's implementation and then later on retirement of a system. And you may wonder, well, what do system engineers do? Well, system engineers do many things, from system analysts, requirement owners, technical client interface, user consumer interface, lifecycle planners. So there are many titles that require system engineers that are not labeled system engineers. But the discipline that you're being exposed to is integrative, interdisciplinary, which means you can go across many different things. So you're going to learn a little about a lot and be equipped with tools that can allow you to then provide value to any decision maker. So what are some system engineering tasks? You can use it's an interdisciplinary approach, where you can convert customer needs to functional requirements and performance measures. And you can lead the requirements analysis, design, synthesis, systems validation to achieve successful realization. These are just some of the tasks that system engineers engage in on a routine basis. And like most disciplines, there are professional organizations, and at West Point, we're engaged in many, but these are some of the core professional organizations in which we're engaged in which you will have the opportunity to do research, present some of your research, work with faculty, and that's the engineering management, or system engineering, operations research, or project management. The Association for Society for Engineering Management, ASEM, fantastic organization, and COSI, focused on system engineering. Informs, the global operations research organization, but there's more within Informs than operations research. And then Project Management Institute, which focuses on the discipline of project management.